We can tell that this is y equals 3x squared and this is y equals 3x by focusing on the origin. Because if I plug 0 into this function, what am I going to get? 0, right? Because anything times 0 is 0. However, if I plug 0 into this function, what am I going to get?
A number.
1. Because anything to the 0 power is 1. So the method for noticing which one it is plugging in for 0. Okay, plugging in for 0 and seeing what happens to my function. Does that make sense? Because obviously you would think that these both could be half of a quadratic function, right? But when you look a little bit closer, you can't. Well, sometimes you're also just given a table. So if you're just given the table, that can even be confusing within itself. So using a table, what you have to pay attention to is your common differences and common ratios. When you're dealing with quadratic functions, which this is our quadratic, right? There's going to be a common difference, a second common difference. So that means that when I'm thinking about how did I go from 0 to 3, what did I do?
Add 3.
Added 3. How did I go from 3 to 12?
Add 9.
How did I go from 12 to 27?
Add 15.
How did I go from 27 to 48?
Add 21.
And how did I go from 48 to 75?
38.
27. Good job. All right, so that's just looking at this. Now, if this is a quadratic, that means that when I find the second common difference, they should be the same. So how would I go from 3 to 9?
6.
How would I go from 9 to 15? How would I go to 15 to 21?
6.
How would I go from 21 to 27?
6.
So I have a common difference.
6.
Okay? It's called a common difference because even though it says plus 6, could that not be written as minus negative 6? And still mean the same thing? All right. So over here we have an exponential function. We have an exponential function. And when we look at exponential functions in a specific domain, along with the quadratic function, they have the tendency of almost looking the same. So we have to be conscious of what we have to compare them. With exponential functions, what you have is a common ratio. That means from one y to another y, there is something you multiplied by, whether a whole number or fraction, to get to that point. So what did I multiply by to get from 1 to 3?
3.
3 to 9?
3.
9 to 27?
3.
27 to 81?
3.
81 to 243. So this has a common ratio. And when we go a little more in depth with exponentials, we're going to talk about that common ratio and what it represents. But I just want you to be conscious of that when you're identifying and applying quadratic functions, that on paper the graph may appear to be exponential, but be careful in examining your table as well. Okay? So here we have quadratic. Quadratic functions generate consecutive y values that have a common second difference. Complete each table below and find the common second difference. So we're going to do the first one together, then I'm going to let you guys fill in the next, and then we're going to talk about what do we think those numbers represent. So here, when I fill this table in, wherever x is, I'm plugging in a 0, right? So I get 0 plus 3 is?
3.
3 squared is?
9.
Times 2 is?
18.
Plus 5 is?
23.
Do the same thing with 1. 1 plus 3 is?
4.
4 squared is?
16.
16 times 2 is?
32.
Plus 5 is?
37.
We have 2. 2 plus 3 is?
5,
5 squared is?
25,
Times 2 is?
50,
50 plus 5 is?
55,
3, plug it in.
6,
6 squared is?
36,
Times 2 is?
72,
Plus 5 is?
77,
Good job. 4, plug it in. 7 squared is?
49.
49 times 2 is?
Give us a minute.
98. Plus 5 is?
103,
And last but not least, 5. 5 plus 3 is?
8,
8 squared is?
63.
8.
8,
What?
no,
I got lost.
64.
64.
What did I say?
I don't know.
I don't know what I said. 5 plus 3 is 8. 8 squared is?
64.
64 times 2 is?
Give us a minute.
128.
128 plus 5 is?
133.
Okay, good job, guys. So, how did I get from one to the other? How do I get from 23 to 37?
Plus 14.
How do I get from 37 to 55?
Plus
What'd you say, Ashley? How do I get from 55 to 77?
22.
77 to 103?
That's a good number.
Huh?
26,
26. And how do I get from 103 to 33?
30,
So when I look for my second difference,
Add plus 4.
Plus 4.
all right, so focus on this number. Do you guys see any relationship between this number and what's up here? Anybody?
No.
No? Not yet?
nope.
2 squared.
What did you say, Yari?
2 squared.
Okay, keep that in mind.
2 squared.
What?
Where'd you get 2 squared from?
Yari said 2 squared. All right, do 4 and see if Yari's idea is true.
Okay.
So do 4 and see if she's right.
Take it off the phone.
You can add this in your head.
It just takes too long.
So we did the same thing like you
Mhm.
did this one. So
Yep.
0 plus 1 is 1. 1 squared is 4.
Y'all got one total on first one.
Negative
No.
4.
107.
We would time square,
What does that
right?
do?
But 110 is 30.
0 plus 1 is 1. 1 squared is
Negative
1.
33.
3 plus 1.
110 minus 3.
Negative 2.
I got 112.
Should have won that one.
It's 107.
It's 107.
Oh, I added.
0 plus 1 is 1.
1 times negative 3.
12.
Oh, yeah, 1 plus 1 is 2. 2 squared is 4. What's negative 4?
I'm gonna get a calculator, okay, Miss Mary?
No, you can do it. We're going to get our brains going.
For number 1,
Oh my
is it going
god,
to
it's
be
really late. See, this would be good to
88.
have first.
Miss Jones? Is this one going to be 88? For number 1.
So 1 plus 1 is 2. 2 squared is 4. 4 times 3 is 3.
What'd you do?
And 110 minus 12 is?
88. Or you guys do math?
Is it 88?
Negative 48, right?
Or is it?
Same.
Did you get 107 for the first one?
Yeah. Oh, right.
That's negative 48.
Oh, I'm sorry.
Oh,
I'm sorry.
10 minus 2 is 8. And then 10 minus 1 is?
I said I'm gonna start.
There we go.
I'm gonna go ahead. Oh, this is good. Okay, wait until my face is something. I know.
You can do it.
You just put.
Miss Ware, I left my phone in here.
You what?
What's the phone? There's 3 phones in one.
Why?
I don't know.
What's wrong with you? How did you lose it?
Like,
What did you be doing with it, Joe?
I don't know.
I
I hope you did
Why would
too.
you keep it in your backpack or in your pocket? That's where I lose it at, and then
One number
they
is
just
good.
break.
I'm doing
So one's coming in today.
No, no.
Oh.
I just gave up. Now I'm just using the calculator.
All right, what's 0?
107,
1,
98,
2,
83,
3,
62,
4,
35,
and 5.
2.
All right.
Way to work either way.
How'd I get
We work together.
107 to 98?
Man, let me go ahead and subtract this. About a good 9.
She just said it.
Huh? Oh, she said 9? Okay. Minus 9? Okay.
15.
Minus 15?
Hang on.
21.
21.
Okay.
27.
Are they all gonna be negatives? We're subtracting, right?
And then 33.
All right. So what is my second difference?
I mean, plus
Negative 3, negative 3.
-3.
I don't know.
See, yeah, that's all I was thinking.
And then again, 6.
And again, and again, and again.
And again, and again.
All right. So we ended up with -6.
Okay.
Hmm.
No.
So is Yari possibly onto something?
No.
Nope.
No.
Because negative.
together instead of. Oh, yeah, because of the -3 squared is.
Oh, so
Negative 3 squared is
Negative
9.
3 squared is 9. Negative 3 times 2 is 6.
Yeah, if you multiply negative 3 times 2, then it's
Yeah, I know what I was
negative 6.
talking
Yeah.
about.
So let's talk about this. So what is something that would make this possible?
Do something times 2 instead of squaring
Okay. But this is just throwing us off because we have a negative, right?
it. No.
No.
Because you're squaring the negative 3.
Okay.
It did not work this time, but it worked the first time because 2 squared is 4.
All right.
You do negative 3 squared, that's 9.
Okay.
You just multiply the negative 3 next
So
to
that
it.
didn't work.
Yeah, and if you do the next one, that's going to be 16.
All right. So let's try it. So this didn't work. So this was a no-go on that theory, right?
Yeah.
Let's try again.
Math.
0.
So we have 7 squared is, oh, that's a big one.
9.
49.
49 times 4?
Oh,
195.
195 plus what?
192.
Oh, 195?
Yeah, 195.
All right.
What's the answer?
What's 6 squared?
36.
36 times 4 plus 1 is
That's good. 145.
145. Okay. 2 minus 7 is,
Negative
squared is,
5. 25.
25 times 4 is,
100.
100 plus 1 is.
100.
All right. 3 minus 7 is,
Negative 12.
4 squared is,
16.
16 times 4 is,
A good number. 64.
and 64 plus 1 is. All right. 3 squared. Negative 3 squared.
37.
9 times 4 is 36, plus 1 is 37. And then we have 2 squared. Gives me
4.
4 times 4 is 16, plus 1 is. All right. Let's see if this will help us come up with a rule.
50.
50? Okay. What happened?
44.
Okay.
36.
Okay.
28. And 10.
All right. So what's my second difference?
Minus 6. On the first one, right?
Okay. Then, uh-oh. Something didn't work. What? That means we have a problem, right?
Yeah.
Because they're supposed to be the same number. So something is not right.
Did we do math wrong?
That's what we gotta check, right? Let's check our math. So 2 minus 7 is? Negative 5 times 2 is?
25.
25 times 4 is?
100.
100 plus 1 is?
101.
So that one worked. So let's check our 1. 1 minus 7 is? Negative 6 squared is?
36.
36 times 4 was 4.
144.
Was it 144? Plus 1 is?
145.
So something didn't work out, guys. Are we sure about the 195?
Nope. No. Okay, so 0 minus 7 is negative 7. Negative 7 is negative 49. 49 times 4 is 196. It's 197.
Ah ha ha, we found our culprit. So this should have been a,
197.
and that makes that a minus 8. Let me clean that up a little bit. That's sloppy. That was just lazy.
So the bigger should be 1052.
Ooh, damn.
There we go.
Damn, Mom.
So it'll be 52.
Didn't get last time.
52.
So this should be 52. Now we're back on track.
I think so.
That'll be 2.
So 52 went down by
I said that.
8, right?
Yes.
44 went to 36 by
Negative 8.
36 to 28. 28 to 10.
Freaking 18. Oh.
No, that's a lot.
Yeah.
That's not right.
It's supposed to be 20. It's supposed to be 20 at the bottom.
It's like this isn't right again. Guys, what kind of math are y'all doing on me?
I said 20, you put 10.
You did not.
Yes, I did. I said 10. My bad.
This is what happens when you
And then I erased the wrong thing.
This is what happens when you make us do it without calculators.
Okay.
Hey, you're using your brains. You just made a couple mistakes at the end.
Oh, I think our brains don't want to do this.
I'm okay with a couple mistakes.
Okay. Are you recording this?
All right. Okay, so theory again. We ended up with.
Negative 8.
All right, so there's 4 and 2.
See, that's not gonna work because there ain't no negative.
And 4 squared is.
16.
So is there another way instead of squaring them? What could happen?
By 2.
I could multiply by 2, and that gives me 2 times 2 is.
4.
That works. What happens here?
Negative 3.
Negative 6. But it don't work on the last one.
Negative 6.
So the last one is a
Go ahead.
stumper.
Go ahead and put that parenthesis, put the negative in front.
So why is it not working on the last one?
You know what, Miss Jones, why don't you tell us why it's not working? I'm guessing. And
I'm just as stump as you.
No,
Why
you're
does
not.
it work?
No, you're
Did
not.
you
On
already,
this
You
one.
know the
you
answer.
already did it in the other class period, so you know.
We didn't get this far.
Oh,
Lies.
So, I don't know why it's not working.
well, I don't know
Is
why.
it because of the negative 7?
Yeah, that's what I was going to say.
No, you wasn't.
No, he wouldn't.
Because of the negative 7?
Yeah,
This is the only one that doesn't have
apply this.
positive.
True.
Okay. Well,
But we wouldn't get the same answer.
because over here we were decreasing and it made sense, right?
Found another one we was adding.
I'm stuck. I'm just so stuck.
Oh,
I just don't understand why it worked over here. Like this one went perfect, right? It made total sense. Let's check up here. We had a 3 and we had a 2. So 3 times 2 is.
6.
That worked too. What a booger.
Oh, make the 4 negative.
Just make it negative.
Yeah.
If I made it negative, what would that do to my function?
Man, I don't know, Miss Jones. How about we just Google it?
What would it do to my function if I make that negative?
No.
What does a negative on the outside cause my function to do?
Move.
It reflects.
Not reflects. So I really don't want to move my function, but there has to be a reason why we're getting negative 8.
You know what? You got 5 minutes. You have 4 minutes to guess.
Mitch, are you being for real or are you acting dumb?
I I need you guys to help me because I'm really stuck.
She really just didn't know.
Well, all of this stuff because we're not gonna get it. I mean,
Is it even a quadratic anymore?
is it a?
Well, why would it not be a quadratic? I have a 2 on the outside. My 2 still exists. All right, so we're gonna write down what we do know.
I just now got stuff.
You roll it down.
Where we at?
At the bottom.
I have to put the little stuff back in the boxes where they belong.
Oh.
I'm going to try to put them back in the box where they belong. That's pretty good, right?
Almost.
There we go. All right, so we do know that how's common second difference relate to the constants. So we have A, C, and D, right? So with A and C and D, what could possibly happen? Everything. Okay. So what does C? What does A normally cause our function to do?
Reflect.
Reflect and stretch and compress. Okay. What does C cause my function to do?
Move
Up and down.
No. We're left to right because we're the inside. We're close to X, right? And D is going to cause my function to do what?
Up and down.
Up or down, up or down, up or down. All right. Got it. So A is our magic number. And A can be determined by looking at what?
Not this.
The 2?
The 2? Okay.
And A.
A is this, right?
Yes.
What if I told you to work backwards?
I ain't got time for that.
We ain't got
Like,
time
what
for
if you
that.
had this and I need you to find A? What would I do to this number to get that?
Wouldn't you
That would be
subtract?
longer.
Wouldn't you do the opposite?
I wouldn't double it. What would I do? How would I go from 4 to
Divide.
divide by what?
2.
Okay, that worked. What would I do here?
Divide by 2.
And that gives me,
-3.
all right. Darn it! If I divide by 2 here, what's gonna happen?
-4.
And we do not have a -4.
No, we don't. Is that no function or graph?
It's undefined.
Yes.
Yeah.
It's fine under.
Maybe that was a mess up on your part.
Maybe you should just being really dumb right now and you're really trying to hurt my nerves.
Oh, well, we got 1 minute left. We can leave.
We're gonna leave you pondering on that.
Wow.
See.